Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. This is the 10th part, right? Or 9 parts I have given. This is the 10th part. In the 10th part, a very important 5-mark question will be there. That is Wheatstone bridge. It is a Wheatstone bridge. Already I have given for problem purpose. Okay. So now 5-mark question. This is the little lengthy question. 5-mark question. Very important as well as gunshot question. Cells are in parallel combination and Wheatstone bridge. These are very important questions, right? Okay, then what is the meaning of Wheatstone bridge? Already I told you introduction, all those things. What is that? So with help of Ohm's law we can't find it. So equivalent resistance between A and B, that means two terminals, correct? So series combination, parallel combination, easily we can calculate, but this is not a series combination, not a parallel combination. Different direction will be there. In that case, so Ohm's law is not possible, right? Not suitable. Therefore, we want to follow Wheatstone bridge method only. Wheatstone bridge method. So Wheatstone bridge depends on Kirchhoff laws. Wheatstone bridge depends on Kirchhoff law. With the help of Kirchhoff laws, we will explain the derivation of Wheatstone bridge. That means balanced Wheatstone bridge. R1 by R2 is equal to R3 by R4. That formula we can derive with the help of Kirchhoff laws. Kirchhoff two laws. One is junction law as well as voltage law. Junction law as well as voltage law. You have to remember voltage law. Okay, again junction law also. Right. So what is the meaning of Wheatstone bridge? So this is the 5-mark question. From here to there still will be there. Right? Definition. What is the definition? It is an arrangement. It is an arrangement of 4 resistance. It is an arrangement of 4 resistances used for measuring one of the resistance. Used for measuring one of the resistance in terms of the other 3. Correct? What is the most important advantage? This one more also will be there. R1 by R2 is equal to R3 by R4. Total 4 resistors are there. Correct? 4 resistance values will be there. For example, in that R3 I don't know, or else R4 I don't know. Correct? So with the help of R1 by R2 is equal to R3 by R4, easily we can calculate. So unknown resistance value. Unknown resistance value easily we can calculate with the help of Wheatstone bridge. This is another important advantage, right? Okay, so then what is the principle of Wheatstone bridge? The principle is Wheatstone's network, right? 2 or more, 3 or more resistors combined together, that is we can call it network only, right? Okay, Wheatstone network consists of 4 resistances, R1, R2, R3 and R4, connected in the form of quadrilateral ABCD as shown in the figure. Quadrilateral ABCD, quadrilateral shape only, that is the Wheatstone shape, Wheatstone bridge shape, that is. Right, second point, a galvanometer. Remember, new word here, galvanometer. Galvanometer is the sensitive device which is used to measure the very small amount of current. Very small amount of current measuring purpose we have to use galvanometer. One more also will be, what is that? Ammeter. Ammeter also device which is used to measure the current. That is the ammeter. Right, voltmeter. Voltmeter is a device which is used to measure the potential difference between 2 terminals. Right, voltmeter always we should connect in the parallel combination, but ammeter we should connect in series combination. Right, we should connect always voltmeter in parallel combination only. Ammeter we should connect in series combination only. Right. Then why? Because this and all we learn already the previous chapters, right? Okay. So that one also will come in the moving charges as well as moving charges in magnetism also. Right. Okay. So a galvanometer of resistance G. Galvanometer also having resistance. That resistance we can represent it as G. Okay. Is connected between B and D. That is. So B and D is a galvanometer. Correct? Same resistor, same instrument, right? Previous problem I took there, here resistor only. Okay, but here I took their galvanometer. Galvanometer also having some resistance. The resistance is G. That resistance is G. Okay, next point. A cell of EMF. A cell of EMF E is connected between AC. Alright, AC. This is the EMF of cell. Cell we should connect in between A and C. This is the E. This is the plug key. K. Right? If this word is most important. If the potential at B and D is equal. If the potential at B and D is equal, then through galvanometer the flow of current is equal to 0. Correct only, right? So at this point potential is same, mean the current cannot flow in this direction. Cannot flow in this direction mean what would be happen? Through in this direction IC is equal to 0. In that case the bridge is balanced. The bridge is balanced. This is the principle of Wheatstone bridge. Principle of Wheatstone bridge. We are having A, B, C, D. So quadrilateral. So here one resistor, all resistors we are connected there. So between B and C, galvanometer also having some resistance. Through galvanometer, the flow of current is 0. Why sir 0? When it becomes 0? Right, that is the point. What is that? At B, at D, the potential is same. In that case, the current cannot flow in this direction, means that current is equal to 0. IZ is equal to 0. This word is most important. Remember. Right, that is the principle of Wheatstone network. Right. So now question is show that R1 by R2 is equal to R3 by R4. Or R1 by R3 is equal to R2 by R4. That is our question. Show that R1 by R2 is equal to R3 by R4. Right. Now proof. Now let I1, I2, I3, I4 and Ig be the currents through R1, R2, R3, R4 and Ig. Right. So I1 current is for example here this is the EMF, the cell, this one cell is given, current is I. Here junction will be there. So 1, 2, 3. Correct? 3 wires connected, that means that is the junction. So junction A and junction B. Yes, and here also one junction will be there at the junction. At the junction. Right. So entering current. Here entering current. Which one? I2 and Ig. This is entering current. This is the leaving current. At this point, this is the entering current. This is the this is entering current. This is the leaving current only. Right. At this point, I is entering current. I1, I2 is the leaving current. The current is divided, mean this one both are in parallel combination. Current is same, mean series combination. Current is different, mean parallel combination. Parallel combination. Right. So applying Kirchhoff laws. 2 laws will be there. We have to apply 2 laws. First one is that Kirchhoff junction rule. Kirchhoff junction law or rule. Okay. Kirchhoff junction rule. Junction rule. So now I will consider 2 junctions. Here one junction, here one junction I will consider. Okay, why? Because here I taking through this direction current is equal to 0. So that's what we want to consider junction B and junction D. With the help of that one, we will get I1 value, I3 value, I2 value, I4 value. Okay, now for that purpose we want to consider junction here and here. For what purpose? I1 value, I2 value, I3 value, I4 value. Okay, now at this point I1 is equal to I3. Correct? At this point I2 is equal to I4. Yes or no? Why? When that is? At this point I will say I2 is equal to I4. Correct or wrong? Yes. When that is? Similarly, at this point I1 is equal to I3. But at this point IA is divided into 2 parts. Mean at this point I is equal to I1 plus I2. At this point. Right? With help of this one, we will say I1 is equal to I3 and I2 is equal to I4. Right? We will see now there. So, for example, here observe here. So, it is the first junction. Now, current is flowing in this direction. This is the I divided into, in this junction, in this path, I1, in this path, I2. So, again, junction will be there. So, at the junction, what would be happening? Current E, this is entering current. Here, two terminals will be there. Okay, now two conductors. So this is the one conductor, this is another conductor. In this direction, if I take Ig mean, in this direction I3 will come. I3 is nothing but, so I1 minus I1 plus Ig. Correct? Sorry, I3 is nothing but, what is I3 is equal to? I1 minus Ig. Divided, not adding there. So this is the Ig is the I3. I3 is equal to I1 minus Ig. Some current is flowing here, remaining current like that only. Next, at this point, how much current is entering? I2 and Ig. I2 and Ig. I2 plus Ig is equal to I4. Correct? Then, at this point, so total current is I. Correct only na? So here, what is that I3? Here I4. So I is equal to I3 plus I4. I3 is equal to how much? I1 minus Ig. I4. I2 plus Ig get cancelled. Therefore, I1 plus I2 at junction C. Correct? Here current can split. Here current can add. Right? So here split mean parallel combination. Here add mean this is series combination. Are you clear? So that our division, current division is correct. So now I can remove this one. Okay. So now you can calculate, you can show that R1 by R2 is equal to R3 by R4. Okay. So first at junction B, I1 is divided into how many parts? Two parts only na? I1 is equal to I1 this one. I3 plus Ig. In this direction Ig, this direction is the I3. So this is the entering current. This one is the leaving current. But this one also not required. I have directly, this is the Ig, this is the I. That means I1 is equal to I3 plus Ig. But according to principle, according to Wirtz-Bridge principle, so at point B, at the point D, potentially is same. So that through galvanometer, Ig is equal to 0. Ig is equal to 0. Therefore, I1 is equal to I3. That is the equation number 1. I1 is equal to I3. Are you clear? That's the first junction law over. Okay, junction law at point B. Alright, next one. At junction D, entering current is how much? I2 plus Ig. Correct, entering current. At junction D, entering current I2 plus Ig. I2 plus Ig is equal to I4, leaving current. So this one. But according to Wirtz-Bridge principle, Ig is equal to 0. Ig is equal to 0. Therefore, I2 is equal to I4. Alright? I2 is equal to I4. That is the first law over. Now, the KJR. What is the Kirchhoff Junction Rule? Finished. Now, we will enter into Kirchhoff Voltage Law. Kirchhoff Voltage Law. Right? Voltage Law. Or else loop rule. So now here we are having two loops. One is closed loop. Remember, A, B, D, A is a one loop. Similarly, next B, C, D, B, B, C, D, B. Like that we are having two loops. So that's what here. So KVL, Kirchhoff Voltage Law. So first loop A, B, D, A. A, B, D, A. Closed loop it depends on only initial and final position only. Initial and final position, voltage law. Depends on only initial and final position. Therefore, loop A, B, D, A. So now here we want to consider path. So path direction, in this direction clockwise also no problem, here clockwise also no problem. So here anti-clockwise, here clockwise also no problem, anything. So here clockwise, here anti-clockwise, nothing will happen. So here anti-clockwise, here clockwise, any direction, or else here clockwise, here also clockwise, or else here anti-clockwise, here also anti-clockwise, any direction you can take, no problem. It is that depends on only initial and final position. It depends on only initial and final position. Right. So now I will consider. So what is that? Loop, closed loop. Okay. This is the one loop I will consider. Loop where to where? So D to A to B, B to D. Again D to A, like that one I have given. First loop. Loop this one. Okay. Loop we can draw like that itself. But remember here direction is the most important. Direction is the most important. And also here also you consider. So in this direction. Okay. Loop rule. So loop ABDA. According to loop rule, the total EMF is equal to the product of current and resistance. The product of current and resistance. Correct? Right. So total EMF in this section, in this loop, there is no battery. Yes or no? There is no battery. That's what here. So total EMF in this case, in this loop, there is no battery. Remember, here battery will be there. This is the different. Correct? This is the, so related to this total. But in this session, there is no battery. So that in this session, EMF is equal to 0. There is no battery, right, in this loop. Here will be there. That is the different. That is the related to total circuit. So total network. Okay. So loop, total EMF. I will consider E. Right. E. Next term. Minus total EMF. And also here. Kirchhoff law. So you can observe here the direction of current and the direction of my path. Both are in same direction, minus only na? Same direction mean minus. I1 R1. Potential. I into R potential. Next, in this direction. So my direction and current both are in same direction. Therefore, minus only. So current is how much? Ig. So resistance G. Next here. In this direction will be there. It comes like that only, na? See that. So here opposite direction will be. The opposite direction mean plus. So how much current? In this path I2 and resistance R2 is equal to 0. The closed loop. Yes sir, the total, the change in potential is equal to 0 in closed path. Closed path. And also here there is no battery, therefore E is equal to 0. And Ig also 0, right? Ig is equal to 0, therefore though this total term is becomes 0. The total term is becomes 0. Then this is a minus will be there, you can transfer to that side. It is a becomes plus. Therefore I1 R1 is equal to I2 R3. I2 R3. So finally I can write here R1 by R3 is equal to I2 by I1. I2 by I1. Are you clear? So now from equation 1 and 2. Equation 1 and 2. Once you can observe here. I1 is equal to I3. I2 is equal to I4 only. Na? Therefore instead of I2 can I write I4? Any objection? No more objection. Okay. Then so I1 is equal to I3. So finally formula, what is that? R1 by R3 is equal to I4 by I3. Equation number 3. Equation number 3. Right. Next term. So second one. So loop. Loop B C D B. B C D B. Loop BCDB. This is the finish. Now this loop BCDB. Right, total EMF E. and direction. So IG and G. Now my direction path is opposite, right? Opposite mean plus only, na? Opposite mean plus. IG, G. No more confusion. Okay. And in this direction, both are same direction mean minus. Current is how much? I3. Resistance is R3. Finish. Next, in this direction, my current is flowing like that. My path is opposite. Opposite mean so plus. Opposite mean plus only, right? Okay. How much current? I4 into R4 is equal to 0. Therefore, IZ also 0, E also 0. Here there is no cell. That is why. Okay. Then this one you can transfer that side. Therefore, what would be happen? So R3 by R3 into I3 is equal to I4 R4. Correct? Minus minus get cancelled. Then I want to R3 by R4 is equal to I4 by, okay, I4 by, so where I done mistake? Here I2, right? Here R2. Here R2. R2 I done mistake, right? Okay. So this is the R2. So this is R2, right? Extremely sorry, none. This is the R2. I done mistake here. I2 R2. I2 R2. Okay. Then next I4 by I3. Equation number 4. Equation number 4. Right? So now from 3 and 4, what we can write? 3 and 4. From 3 and 4. From 3 and, right. So from 3 and 4. What we get at 3 and 4? What is third equation? R1 by R2. R1 by R2 is equal to LHS. R1 by R2, RHS, I4 by I3. You can observe here. RHS, I4 by I3. Both are equal only, na? Therefore we can equate LHS. What is LHS? R1 by R2 is equal to R3 by R4. R3 by R4. Right? This is our formula. Or else R1 by R3 is equal to R2 by R4. R2 by R4. Any section, no problem. R1 by R3 is equal to R2 by R4. Or else R1 by R2 is equal to R3 by R4. In some derivations, we will consider as a P by Q. P and Q like that one. This is the P, is the Q, this is the R, this is the S. Therefore, what will come here? P by Q is equal to R by S. This form also correct. Right? Instead of R1 I took there. So what is that? P instead of R2. Alright? I will consider here Q, P, Q, R, S. P, Q, R, S. P by Q is equal to R by S. P by Q is equal to R by S. Or else this is the R1, is the R2, is the R3, this is the R4. Correct? So R1 by R2 is equal to R3 by R4. Or else P by R is equal to Q by S. Q by S. In terms of P, Q, R, S. That means P also resistance. P is resistance of R1. Alright? So what is the advantage? What is the user? So if for example I don't know this value, I know this value. P is R1 is equal to 2 ohms. This is the 3 ohms. This is the, what is that? 3.5. So 3 or 4 ohms. Like that will be there. Now I don't know R3 value. In that case, we have to use formula this one. What is that? R1 by R2 is equal to R3 by R4. So now I want to R3. Therefore, R3 is equal to R1 by R2 into R4. R1 is equal to how much? 2 by R2, 3 by 4. Therefore, 8 by 3 ohms. What is this? R3. So like that we have to find unknown resistance of resistor. We can find unknown resistance of resistor. That resistor value we don't know, that is unknown value. So we want to calculate. So with help of P by Q is equal to R by S. P by Q is equal to R by S. With the help of that one, easily we can calculate. So unknown resistance value. This is the Wheatstone bridge. Right, but formula is same. What is that? R1 by R2 is equal to R3 by R4. Is a derivation for 5 mark purpose. Are you clear? Okay, now we will solve some problems based on this. Right, one problem I have given, see that. Find current in each branch. Find current in each branch. So given circuit like that is given. Given network is like that will be there. Okay, so here this is the how much is given, current is, here voltage is 10 volt is given, here voltage is equal to 5 volt is given circuit like that is given, but already I given values. Once you can observe clear diagram. A, B, C, D and E. A, B, C, D, E. At E, one battery will be there, one cell, that potential is equal to 5 volt, that EMF is equal to 5 volt. Here one cell will be there, it's a cell, this cell EMF is equal to 10 volt is given, 10 volt. Here resistance 4 ohms, here resistance 2 ohms, here resistance 2 ohms, here resistance 1 ohm, here resistance 4 ohms. Each resistor, the flow of current is equal to how much? Find the current in each branch. In this branch current is equal to how much? In this branch current is equal to how much? In this branch current is equal to how much? In this branch current is equal to how much? In this branch current is equal to how much? Like that they given, right? So now I will give you these values once you can observe. So now first this is the high voltage will be there, no? Here 5 volt only, that's what I will consider 10 volt here. This is the first I1. This is the I will consider, this is the current is I. Okay, at this junction current is divided into two parts. In this direction if I take I1 main, so remaining current here how much will come? So this is the I1, remaining current is how much will come? I minus I1, correct? I minus I1, that means in this branch I minus I1 current is flowing up to here, again junction. Now top junction, top network you can observe one. This is the I1 current flowing through 4 ohm resistor, again will come junction here. Okay, now here this is the I2 current, this is the I1 over, now this is I2 I will consider. I2 current comes here, this is the I1 current comes here, this is the junction. So entering, correct? Now leaving current here. In this direction is the leaving current. How much leaving current? This is the I1 current, this is the I2 current, total current in this direction I1 plus I2, correct? Yes, I1 plus I2. So in this total circuit current is I2, meaning in this also I2 only, right? So that now I given I2. Okay, now here you can observe this branch I minus I1, here junction will be there. Entering current is how much? I minus I1. Okay, but junction here leaving this side and this side. This side current is already we got how much here? I2. Remaining current is we want to subtract from here only, na? I2. So that is I have written here only. That is the, so I1, I minus I1 minus I2. Mean in this branch I minus I1 minus I2 current is flowing. At junction C, this is entering current, this one also entering current. Again both are combined here, again one path will be there here. So how much current will go this side? So here already I current will be there, no? In this direction I only, na? See once again observe here is the I1 I2 plus I1 I2 is a minus I1 minus I2 get cancelled, so that I will go. So our circuit system is correct. That means a current distribution is exactly correct. First you want to distribute the current equally, that is the most important. Alright, okay, now loop ABCA, ABCA, I took the clockwise direction. This is the clockwise direction I took there, clockwise, okay, clockwise. Are you clear? Okay, so now This one, if you observe this one, this is the lower, this is the higher. The current is moving from lower to higher, lower to higher. Positive or negative, I have given again. See that higher to lower is negative, lower to higher is positive. So that lower to higher is positive. So plus 10 volt. 10 volt. Next, this junction of this loop I'm seeing. Right now here, this is over. Next here, the direction of current and loop direction both are in same in minus only, right? So minus, resistance is how much? 4, current is how much? I1. So 4I1. This one also finish. Now next this one, current is moving downward. My path direction also down, both are in same direction means minus. How much resistance? 2. Current is how much? I1 plus I2. So I1 plus I2. Finish. Next here, this is the direction of current, is the direction of path, both are in same direction. Therefore minus. Current resistance is how much? 1 ohm. So 1 into current I. So that is equal to 0. Current total potential is equal to 0 in changing potential 0 in the closed loop. Right. So now you can observe here 10. This is the minus 4I1 minus into plus minus 2I1 minus 2I plus 2 plus I2 minus 2I2 minus I is equal to 0. This minus terms all in still you can transfer to that side. Before that you can add it. So minus 4I minus 2I. Total how much? Minus 6I minus 2I minus I. This total you can transfer to that becomes plus. Therefore 6I1 plus 2I2 plus I is equal to 10 is the equation number 1. Equation number 1. That is loop is understood, right? Okay, next loop 2. Loop A, C, D, A. Loop A, C, D, A. So now I took like that only. Correct? So now you can observe here, this is the higher, this is the lower. Higher to lower negative. So minus 10 now. So current direction, my path direction, both are in opposite. So plus. Again, both are in opposite plus. Here also opposite plus. Correct? Therefore, minus 10I plus minus 10 and this one. Current is I, resistance is 1. 1 into I only. Plus resistance 2, current is I minus I1 minus I2. I minus I1 minus I2 into next in this direction. So opposite only na, resistance how much? 4. Current is equal to I minus I1. So 4 I minus I1 is equal to 0. Right. So now this 10 transfer to that becomes plus. Now I 2 into I, 2I, 2 into minus I1 minus 2I1, 2 into minus I2 minus 2 into I2 plus 4 into I, 4I, 4 into minus I1, 4 into I1 is equal to 10. Correct? Now we can add it. So here 4I is a 2I, here 1I. So total 7I. Next minus 2I1 minus 4I1. So minus 2I1 minus 4I1 minus 6I1. Next minus 2I2 is equal to 10. That is equation number 2. Next this loop you can observe that loop. Okay. So now the loop. What is the loop? D C B E D. D C B E D. Right? Now here we can observe now. So resistance how much? 2. Current is this one. Both are moving in the same direction. Same direction only, na? Same direction. Therefore minus. So minus 2 into current how much? I minus I1 minus I2 plus. So next, this is the my path direction. This is the current. Both are in opposite. So plus. Resistance how much? 2. Current is I1 plus I2. This path I1 plus I2. Okay. Next here battery will be there. So now my path direction is, this is the higher, this is the lower. Higher to lower. Higher to lower is equal to negative 1. Therefore minus 5 ohms. Sorry, minus 5 volt. 5 volt. This one transfer that side. It becomes plus only. So now minus 2 into I, minus 2I, minus into minus plus 2 into I1, 2I1, minus into minus plus 2 into I2, 2I2. Next 2 into I1, 2I1, 2 into I2, 2I2 is equal to 5. Correct? So now we can add it. 2I1, 2I1, 4I1, 2I2, 2I2, 4I2, minus 2I is equal to 5. Equation number 3. Finish. Next, from 1 and 2. Equation 1, equation 2. Okay. So what is the equation number 1? 6I1 plus 2I2 plus I is equal to 10. Here, minus 6I1 minus 2I2 plus 7I1. I is equal to 10. So no need to subtract, just we can add it. So minus 6I minus plus 6I plus 2I minus 2I get cancelled. Therefore 7I, 1I. So 8I is equal to 10 plus 10, 20. Therefore I is equal to how much will come? 20 by 8 is nothing but 2.5 ampere. So IA got. IA is this branch. This branch current is equal to how much? So 20 by 8 amperes. 20 by 8 amperes. One branch over. Next, I2 current and I1 current I want. So I1 purpose, I2 purpose, I can use equation 1 and equation number 3. Right? Equation 1, instead of I1 you have to substitute, instead of I you can put I value. I value how much? 2.5. So 6 I1 plus 2 I2 plus I value how much? 2.5 is equal to 10. Next, third equation. What is third equation? 4I1 plus 4I2 minus 2 into I value how much? 2.5. 2.5 into 2, 5 is equal to 5. But balancing purpose, first equation I multiply by 2, second equation I multiply by 1. So 2 into 6, 12 I1, 2 into 2, 4I2, 2 into 2.5, 5, 10 into 2, 20. Next, this and all everything as it is. Now you have to subtract. Yes, I subtracted minus and minus, here plus, here minus. So 4I2 minus 4I2 get cancelled. So 12I1 minus 4I1. So subtract means 8I1 will come is equal to, here, what is that here? 5 plus 5, 10. Here 20 minus 5, 15. Correct? So 15, this 10 transfer, that's why becomes minus. Therefore 15 minus 10, 8I1. 8I1. So 8I1 is equal to, I1 is equal to, here 15 minus 10, 5. This is 5 by 8 amperes. That is the I1 over. Next, finally I2. Right, we know I1 value as well as I value. Right, that value you can substitute any equation. So now I took there, so one equation. Which one? This equation. 4I1, 4I2 minus 2I is equal to 5. So now I want to I2. Correct? This one transfer, that's why becomes a plus. This one transfer, it becomes minus. So 5, 2 into I value how much? 2.5. 2.5 into 2, 5. So minus becomes plus. So 5 plus 5 is a 4I1. 4 into I1 value how much? 5 by 8. 5 by 8. Correct? So becomes minus 1. Minus 4 into 5 by 8. So 4 ones, 4 twos, 5 by 2 will come. 5 by 2. Correct? So this is the how much? Is the 10. This is the 2.5. 10 minus 2.5. How much? 10 minus 2.5, 7.5. This is the 4 transfer this side. 7.5 by 4 is equal to 1.875 amperes. So I got I1 value, I2 value, I1, I2, I value. So with the help of all branches. So now here I branch, this branch current is equal, I is equal to how much? 20 by 8 minus I1. I1 is how much? 5 by 8 is equal to 15 by 8 amperes. Correct? In this branch how much? 15 by 8 amperes. So this I1 already we got. I1 is equal to 5 by 8 amperes. Correct? In this branch. I will over 20. So next in this branch I want current. here, this through this resistor. How much? So I is equal to how much? 20 by 8 minus I1 is equal to 5 by 8 minus I2. I2 is equal to how much? So 7.5 by 4. So if you do calculation, you get answer. That is in this branch. Similarly here also. Here is how much? I1. I1 is equal to 5 by 8 plus I2 value 1.85. 1.84, that means 7.54. Do calculation, you will get answer. Right? So each branches will get answer. This is the one problem. Right? Very, very, very important this problem. So complicated circuit problem based on Kirchhoff laws. Correct? Which one bridge is direct? That is the bridge is balanced to me. So R1 by R2 is equal to R3 by R4. Series combination, parallel combination. Right? Next one more problem. Right. So next problem. Find current in 1 ohm resistor. So here 1 ohm will be there. So through 1 ohm, how much current is flowing? That current I1 is equal to how much? Right? I decide like that I1 only. So I1 you can calculate. So here circuit like that is given. Okay, network like that is given. So this is a 9 volt battery. This is the 6 volt battery. Okay, here 3 ohms, here 3 ohms, here 1 ohm, here 2 ohms. Like that is given. Okay, that is the given question. Right, everything is fine. So now first one here, we want to arrange the current. Right, current. So first start from here only, right? This is the 9 volt. This is the 9 volt. So 9 volt I is the higher voltage, right? That is why here I. So going in this direction. So here junction will be there. So now here this is the I2 I will consider. This is the I2 I will consider. Therefore in this direction how much will come? So I1. This is the I2. That means I is divided into I2 and I1. Correct? I is divided into I1 and I2. Mean total I is equal to I1 plus I2. Total I is equal to I1 plus I2. This is entering current, this is the leaving current. I2, this is the I1. So now again here will come, this is the I2, here junction will be there. So this is the I1 current, this is the I2 current. Yes or no? So I1 and I2 entering here. So again we'll go in this direction. So in this direction total current is how much? This is I1, this is the I2. I1 plus I2 is equal to I. Same one, na? So our current division is correct. Division of current is correct. Okay. Now first one, loop A, B, C, D. A, B, C, D. Or else loop I took like that only, right? So clockwise I took that. So A, D, C, B. A, D, C, B, A. That is our loop. A, B, C, D, A. Right. So this is the higher, this is the lower. So my direction, my path direction is low, higher to lower. Higher to lower is negative. So 6 volt minus here current. Not there here, no resistor. Therefore, not next again here. So current direction, path both are in same direction. Same direction means minus. How much current? I1. Voltage 1. 1 into I1, I1 only. Plus next here. So this is the path direction, this is the current direction. Both are in opposite. Opposite means plus. How much resistance? 3. Current is 2 in this branch, I2. 3 I2 is equal to 0. 6 you can transfer that side. Therefore, 3 I2 minus I1 is equal to 6. Equation number 1 finish. Next, second one. Loop B, C, P, Q, B. B, C, P, Q, B. Alright? Okay. So, current is entered in this direction, my path direction is both are opposite. Opposite means so plus. How much resistance? 1 ohm. Current is I1. So 1 into I1, I1. Next here also opposite. 2 into I. 2 into I, 2I. So now higher to lower is minus 9 volt. Plus here in this direction. Current is how much? I1 plus I2. Resistance is the 3 ohm. Both are opposite means plus. 3 I1 plus I2. Are you clear? Okay. So I1, this 9 is transferred, that becomes plus. Now I is equal to what? I is equal to I1 plus I2 only, na? Therefore, instead of I have written I1 plus I2. So I1 plus 2 into I1, 2I1. 2 into I2, 2I2. Directly I have given. Plus 3 into I1, 3I1, 3 into I2, 3I2. Here instead of I have written I1 plus I2 into 2. 2 into I1, 2I1. 2 into I2, 2I2. That is. Okay. Then now you can add this one. I1, 2I1 and 3I1. 3 plus 2 plus 1 is equal to 6. 6I1. Next. 2I2, 3I2. So 5I2 is equal to 9. Equation number 2. Now target is I want to I1. I want to I1. So from equation 1 and 2. From 1 and 2 what we can write? What is the first equation? 3I2 minus I1 is equal to 6. Second equation 6 plus 6I1 plus 5I2 is equal to 9. So now I want to I1. Therefore I can equate I values. So that here 6 will be there. Correct? That means I want to equate these values. I2 values I can equate. In that case I2 get cancelled. I will get I1 right? Here 3 will be, here 5 will be. Therefore this equation multiplied by 3, this equation multiplied by 5. So 5 into 3, 15I2. 5 into I1, 5I1. 5 into 6, 30. 3 into 5, 15I2. 3 into 6, 18. I1 is equal to 3 into 9, 27. Now you can subtract. So minus, minus and minus. Get cancelled. Minus 5 minus 18 minus 23 I1 and 30 and 27. So plus 3 will come. So I1 is equal to minus 3 by 23. So I1 is equal to minus 0.13 ampere. Correct? So, but here direction minus mean opposite only. That means my assumed direction is in this way will be there, but actual direction what will come? From B to C. Right? The direction is from here to here will go opposite direction. So I is equal to minus 0.15 amperes. That is the problem. Right? Okay. Next. Right. So NCERT text 2 problems. 3.1 as well 3.2. These two problems are NCERT text 2 exercise problems. So the storage of car. The storage of a car battery has an EMF of 12 volts. Okay na? So battery, I mean the storage of battery of a car. The storage battery, as I missed out here, the storage battery of a car has an EMF is 12 volt is given. If the internal resistance of the battery is 0.4 ohms, okay, 12 volt to 0.4 ohms, what is the maximum current that can be drawn from the battery? That means there is no external resistor. Okay, na? Therefore E is equal to 12 volt is given, R is 0.4 is given, R is equal to 0, capital R. I is equal to what? You know formula, I is equal to E by R plus R. Correct? Therefore E is equal to how much? 12. R is equal to 0. So R is small r is 0.4. 0.4 means 4 into 10. Okay. So 0.4 into 10 by 10, that is. So now how much will come? So 30 amperes. Simple, very simple. NCERT problems. Right, next. A battery of EMF 10 volts and internal resistance 3 ohms is connected to a resistor. Right, circuit diagram like that. Like that will be there. This is the 12 volt, right? 10 volt. So plus, and resistance is equal to, we don't know, which is having internal resistance. How much? Internal resistance 3 ohms. Is the 3 ohms will be there. Is the I is equal to how much? 0.5 amperes. Then R is equal to what? As well as, so when the switch is closed, when the circuit is closed, so for example, in this manner I will give you. So here, terminal potential difference. When the circuit is closed, then what is the V value? Are you clear? Okay. Then first E value 10, R value is 3 ohms, and I is 0.5. R is equal to what? V is equal to what? So I is equal to E by R plus R formula, you know. Correct? I want to, what I want. So capital R, right? Therefore this will transfer that side. Therefore, R plus R is equal to E by I. Right? Okay. E value how much? E value is 10 by I value 0.5. Mean 0.5 mean 100 by 5. That is equal to 20. So R is equal to 20 minus small r. Small r value how much? 3. That is equal to 70 ohms. This is the R. First question finished. Next, second question. V is equal direct I into R. Or else V is equal E minus IR also, no problem. So V is equal to E minus I into R. E is equal to how much? 10. I is equal to, so 0.5. Okay, 0.5 into 3. So 10 minus, this is the 1.5. Is equal to how much will come? So 8.5. Correct? V. 8.5 volt. Right, here also I is equal to how much? I is equal to 0.5, R is equal to 17. So 17 5 ja 85. So 8.5 volt. Right? Okay, next. Right. So 2017 month, this for 2017 March. This one. So very important problem, this one. What is the given? When two resistors are connected in series combination, two resistors connected in series combination with a cell of EMF is 2 volt and negligible internal resistance. So R is equal to 0. Negligible internal resistance. Right? A current 2 by 5 ampere flows the circuit. So how much current is flowing here? So I is equal to 2 by 5 amperes. In the series combination, so this is a 2 volt only. R1, R2 value we don't know, but I value, they given I value how much? 2 by 5 amperes. 2 by 5 amperes. Okay. Next, when the resistors, same resistors connected in parallel combination with the same battery. So in that case, the current, main current, not a I1, I2, I is equal to how much is given? 5 by 3 amperes. So here this is the I is equal to how much? So 5 by 3 amperes is given. Here also internal resistance negligible only. Same battery only, na? I did not change. Calculate the resistances. Calculate the resistance. Right? R1 is equal to R2 is equal to what? Okay. So in series combination, you know formula. What is that? So I is equal to E divided by R S plus smaller. Correct? A series combination. Series combination means here this is the RS. I have written RS only. Now in a resistance 0, I want to RS. RS first, before that I is equal to how much? I is equal to 2 by 5. Is equal to E is equal to how much? E value 2. RS R1 plus R2. Correct? 2 get cancelled. Therefore R1 plus R2 is equal to 5 ohms. Equation number 1. Similarly from there. So same formula, right? So I is equal to E divided by RP plus smaller value is equal to 0. Right? So I value how much? 5 by 3 is equal to E value is 5 by 3. E value is equal to 2. RP value we don't know. Correct? So now this one we can write it RP this side. RP is equal to 2 3 just 6 by 5. What is RP general formula? RP general formula. RP R1 R2 divided by R1 plus R2, right? Only 2 resistors will be there. 1 by R1 plus 1 by R2. R1 R2 divided by R1 plus R2 is equal to 6 by 5. R1 plus R2 value how much? 5 only, na? So this 5 get cancelled. Therefore we got here, what is that? We got here R1 into R2 is equal to 6 ohm square will come. 6 ohm square. Correct? Right. So now I want to individual. Therefore I want to follow R1 minus R2 whole square formula. You know this and that. Correct? In the capacitor also same problem will be there. Right. So this one I will write R1 plus R2 whole square Okay, minus 4 R1 R2. Correct, man? A plus B whole A square plus B square 2AB minus 4AB. 2AB get cancelled, minus 2AB will come. Alright? Then R1 plus R2 value how much? 5 only na? So 5 square means 25. Minus 4. R1 and R2 value 6. 6 4 is 24. That is equal to 1. Plus or minus 1 ohm. Correct? This is the R1 minus R2. I got. Equation number 2. So from 1 and 2, what we can write? R1 plus R2 is equal to 5. R1 minus R2 is equal to 1. So get cancelled. How much will come? 2. R1 is equal to 6. 2 3s. Correct? Therefore R1 is equal to how much? 3 ohms. Similarly R2. This one. 5 minus R1. So 5 minus 3 is equal to 2 ohms. This is the R1 value as well as R2 value. So R1 is equal to 3 ohms. R2 is equal to 2 ohms. Right? Okay. Right, my next problem is, so 2015 problem, 2015 March. So very important this one also. What is that? Two cells of EMF 2 volt and 4 volt. E1 is equal to 2 volt, E2 is equal to 4 volt. And internal resistance R1 is equal to 1 ohm, R2 is equal to 2 ohms internal resistance. Respectively are connected in parallel combination. So as to send the current in the same direction. Through resistor. Through external resistor. Its resistance is equal to 10 ohms. R is equal to 10 ohms is given. Then find the potential difference across the 10 ohm resistor. 10 ohm resistor here. So I want to potential difference. I want to 10 ohm resistance potential difference. V is equal to how much? So here I value. This is I value. This is the R value. I into R is equal to V only, right? Correct? I into R is equal to V. Therefore I want to I value. You have to find it I. Correct? Therefore I formula I is equal to E equivalent by R plus R equivalent. Yes or no? Series parallel combination, right? That's why I have given E equivalent. Resistors also parallel combination. Therefore I have given the resistance E equivalent. So in this session already given E equivalent for two resistors. Two resistors mean E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Or else E1 R2 plus E2 R1 divided by R1 plus R2. Correct? So find it. So E1 is equal to 2 into R2, 2 to the 4 plus E2 4 R1 1 plus 4. So 1 plus 2 3. So 8 by 3 volt. What is this? E equivalent. Similarly R equivalent. What is the formula? 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2, or else R1 R2 divided by R1 plus R2. 1 by R equal is equal to 1 by R1 plus 1 by R2, or else R equal is equal to R1 R2 divided by R1 plus R2. So 1 into 2 divided by 1 plus 2. So 2 by 3 ohms. Right. I is equal to, what is I formula? E equivalent. E equivalent by R plus R equivalent. R equal is equal to how much? 8 by 3. Correct? 8 by 3 by R value 10 plus R equivalent 2 by 3 is equal to 2 by 3 is equal to how much will come? So 8 by 3 divided by, so 30 plus 2 32 by 3, so get cancelled. So 8 1, so 8 4, so 1 by 4. I is equal to how much? 1 by 4 ampere. Then V is equal to I into R, 1 by 4 into 10. So 10 by 4 is equal to 2.5 volts. 2.5 volt. This is the one method. Another method also will be there, that is the based on Kirchhoff laws. Okay, method 2 I want to do, just I will give you a hint, you have to do it. So first cell, it's a resistance. Here external resistor. Right? So next cell, its internal resistance is the E1, this is the R1. E1 is equal to this R1. Is the R is equal to 10. Is the E2 is equal to 4. R2 is equal to how much? 2. Correct? So 2 ohms. 1 ohm, 2 volt, 10 ohms, 4 volt, 2 ohms. Now current. This is I will consider I1. This is I will consider I2. Or else this is I2, this is I1, no problem. So now current is comes in this direction. So total current here, how much? I1 plus I2. If I know I1 plus I2 value, R value, okay, easily I can calculate R value, V value, right? V is equal to R into I1 plus I2. This is the formula. Now target is I1 plus I2 is required. So that we want to follow which method? So again Kirchhoff law, voltage rule, right? So voltage rule we have to follow in this direction. So this is the lower, this is the higher. Lower to higher, again this is the lower, this is the higher. This is going from lower to higher. And current direction, this is both are same direction, so minus. Again here opposite, so same direction only, same direction means minus. Here, so same direction minus. Again here, same direction minus. We have to calculate with the help of Kirchhoff voltage law. So loop 1 and loop 2. With the help of this one, we will get I1 plus I2. After that, we can put here, you will get another same one, 2.5 volt will come. 2.5 volt. Right, ma? So this is the based on Wheatstone bridge as well as Kirchhoff voltage law and junction law problems. Okay, 2015, 2017 problems, 2017, okay, remaining problems are very easy. 2016, 2000, next 19 problem also easy. Right? You have to practice that problems. Next, last two concepts will be, that is a meter bridge and potentiometer, as well as power topic will be there. Okay, next one more session I will complete this chapter, or else one more session. Alright, okay, thank you to one another. Thank you.